All right. So welcome back. Today we are starting a series on introduction to gridded ocean data with xarray. Xarray is a really foundational um, package in Python for working with gridded Earth data. And today it's going to be an introduction, pretty easy introduction. Don't worry if you've never used it before. We'll get you started. And then I'll show an example with OPeNDAP. And then I will, next week, I'll be doing more, but we'll work more with some other types of data servers that you're liable to run into and show you how how xarray will really help you working with those data. All right, so if we go to the website here, share that chat. Oh, come now, let me chat with you. Okay, that's where I am. And we are, unfortunately, I didn't get it linked up here, but you'll see it over on the left side here. It says Intro to xarray. So let's first talk a little bit about, how xarray came to be. xarray came as part of the Pangeo community, the earth science community, that recognized that it was just too hard to work with these really massive data sets. If you have a small data set, yeah, you can load that into memory and that's fine. But when we start working with massive data sets, many terabytes or even petabytes, you're not loading things into memory. And you also, when you start to work with really large data sets, you need to have a way to do your operations in parallel. And when you're working with gridded data, it's very easy to parallelize your operations. But you really, for the regular user to be doing these things, you don't want them to be designing those algorithms. You want that all to be happening in the background. And xarray, so this was kind of the first version here, or the first vision, is that, we have our data here and we have this in the cloud, which could be a bucket, cloud storage, but also like OPeNDAP would be an example. ERDDAP, also built on the similar infrastructure. That's also in the cloud. So it's different though than like FTP. So FTP we're going to be downloading, but these other technologies, we are able to stream data in. That means we don't have to like download all the data. I mean, we can also do this downloaded, but we don't have to. But it's still like really massive data sets, these massive gridded data sets. And we want both a package that allows us to load that data in and load it in lazily. So if we are going to do something with, say, terabytes of data, we definitely don't want to have to load that into memory to understand it. So xarray allows us to do what's called this lazy loading. It reads the metadata, information about the structure of your gridded data. And you'll see that. But also importantly, it's integrated with another package that's called Dask. And Dask is working in the background to figure out how to do things in parallel and how you will chunk your data to do operations in parallel. Like what kind of operations? So let's say, you'll see in one of our examples that, say we want to have the mean for a a region, a large region. So you know, think about like the North Pacific. You know, a lot of our indices will be like the mean of sea surface temperature over a large region. And that kind of operation is very easy to do in parallel. It's easy to do in chunks. And with xarray, it's integrated to Dask in the background. You won't even be aware of it. And it does that computation in parallel for you. So you're not having to load in an entire grid to try to take the mean, say. Mean is just one example. There are many, many, many mathematical transformations of data, means, variance, standard deviations, you know, all kinds of different things that we do that can be done in parallel in a chunked fashion. And Dask works in the background and figures out how to set that up for us. So you can see here, this is kind of visualizing what's going on in the background. It's creating this graph, does it for us. We're not going to be working with that aspect of X-ray really much today. We might not work with it at all today. I'll get into it more later. It'll become important for certain types of analyses. Another kind of interesting thing that they did is they did something called HoloViz, which is a way to visualize massive data sets. And it's very clever. I'll show this in later weeks, but what it does, you can like visualize a massive data set, and it does this kind of downscaling for you. And then as you zoom in, it loads more and more of the data. So you're able to like plot something without actually loading in terabytes of data into memory. Okay, so that's the background there, and that's the original platform, the original idea started, I should look up when it started, but it was well over a decade ago. Today, X-ray lives within a very rich ecosystem of tools that are all working together. So we were working with TensorFlow when we did the convolutional neural networks last week. You know, it's all these things are working nicely together. Okay, so let's start off with an introduction to X-ray using and learn some of the really basic functions. So we're going to start off with this subset and plot. Click that. So yeah, just click on that link there. And let's see here. Oh, we have a few more people. So let me copy this link again. Copy link. Okay, there we go. Yeah. So click on that. Look on the left for the intro to X-array, and then click the subset and plot tutorial. I'm going to work on this in Colab. You can also click this to open it in our Jupyter Hub. So one thing about our Jupyter Hub, you have access to this. It's a training platform to help people learn cloud computing, help them learn advanced geospatial analysis. You won't have to install anything. It's all set up. If you're working with NASA Earth data, it's fast. It's in the same cloud region, so it's optimized for that. So just reach out to me if you'd like access. But we're going to do Colab just so that you don't have to be signed up for that. So let's go ahead and click that. All right, so now we're in Colab. And so first off, what we're going to do is we're going to open up a single file and crop it. The example I'm using today does use Earth access. So you will need to run that. That's right. In our other examples, we won't be using Earth access. We'll be using data we don't have to authenticate to, but I grabbed this tutorial from one of my, hey, what are you complaining about? One of my, oh, that's what I just say about exclamation mark. It doesn't like that. What? Oh, come now. What are you upset about? Okay, fine. Wanted an exclamation point there. Okay, I guess I wanted an exclamation point pip install. So we need to install that. And then we're going to import it. You just ignore those errors if you get those errors. So now I can run that. Okay. And when we are getting data from NASA Earth data, we're going to work with some SST data. We do need to authenticate. And yeah, so it's going to persist this information. Right. Really have an easier to remember user password here. Response. Okay, hopefully that worked. Okay, great. And so the first thing that we're going to do here is get some data. And what I'm going to do is I'm getting this data set. It happens to be a sea surface temperature data set. And I'm going to grab 4 days of data. This is a daily data set. And with Earth access, what it's doing is it's going to the NASA catalog and it's giving that information about the data set I want and the date range that I want. This happens to be global data, so bounding box not needed, but I could pass in a bounding box. Okay. Great. And then this is, let's show you what this is so you understand it here. Right. So what the results that it's giving me, it's going to their catalog and it gets the link to where the data is. So here's the link. And what you can see here is that it is an NC, it's a netcdf file. So I'm going to be opening up a netcdf file with xarray. This netcdf file is in cloud storage. And what this line here is doing is it is setting up the HTML headers to be able to access that data set that's in cloud storage. So I guess you don't really have to care about that, but until you start trying to do this yourself, and then you have to know that interacting with cloud storage requires some file spec kind of things that Earth Access takes care of for us. All right, so what's happened here is I've opened up that link to some data that's in a cloud bucket, and I use xarray to open that up and create this xarray data set. If you're not a Python user, I should show you one thing here, which is that in Python, when you import packages, you'll often import them as give it a shortcut name. So in this case, I'm importing xarray. So to use a package, you need to import it. But I'm going to call its functions by XR rather than writing out xarray all the time. And there's some really standard shortcuts that people use. I mean, I could use anything, but XR is the standard one you'll see. Okay. Oop. Hey, goodness gracious. That was longer than I wanted. Okay. Great. Okay. So what is happening here? This is xarray, and I'm using the xarray open data set. xarray has two really common open functions. One is open data set. That's to open a single file. And then the other one is OPeNMF dataset. And that's if you have links to multiple files, it can open all of those together. We'll see that in a moment. In this case, I'm opening one data set. So let's go down here. I'm just going to skip over this part for a moment. And what we can do is if we type out the name of the variable that we just opened, so I assigned it to the name DS. If I run that, you see that xarray shows me the format of this data. Now, what's important to know is, like I said, it's doing this lazily. xarray does this lazily. It has loaded the information about the data set, but it hasn't actually loaded the data itself. Look at this lat long. This is a very fine scale data set. I would probably crash the memory of this little Colab instance that I'm using. I don't know how much RAM it has, but it doesn't have very much. But that's okay, because it didn't have to do that. It's just giving me the information about the data set. And I can do things like look at, okay, it's just got one time point. So I just opened one day. I can look at the lat long. I can see the, oh, wow, that's pretty fine scale. Probably click on that and see a little more about it. Yep, it's very fine scale. Same with my longitude. I can see it goes from -80 to 180. There we go. Very important here, I can see what the data variables are. So it's got SST, error, this is a landmass, it's got CI's fraction. So I can see all the things that are in this data set. I can see what the coordinates of them are. In this case, all of these have time lat long, so same as these up here. That won't always be the case. For example, you could have a variable that doesn't vary with time. Let's say if there was a bathymetry layer, that might just be lat long. But these all vary with time, as we can see. I can also look at attributes. So see about this data set and get all the background about it. So all of that just from this xarray data set output. We can get some other things from it. If we do variables like I did, normally I just print it out and look at it, but sometimes you might want to run something like this and it'll print out your variables for you. You can also get the attributes for variables. For example, let's look at the SST. So first thing you can see, this is has, you know, like standard attributes. So if somebody has written a nice data set for you, they'll have various standards, so like standard name. Great. Okay, so now let's begin to learn some of the really basic functions. First basic functions are selecting. How do we subset our data? And I'm actually going to get a new code cell. So I just click that to get a code cell. And I'm going to do DS and then iCell. So with iCell, you are selecting by indices. So I could say, let's do lat equals 0. So what I'm doing is I'm picking the first latitude. I didn't say which one. I just said I've picked the first one. The first one happens to be this. And so what you can see here is now latitude doesn't appear up here because I sliced it. I picked one. And there it is. I just picked that one. And the other ones are still there. I could pick the second one for that one. Let's see what happens. And now those disappear. We see I've got this. And I've got that. Surprised that's my second one. Let's do something else. Okay, yeah, there we go. Now it changes. Okay, so I've just picked one. So that, if you wanted to just pick like by the index, you could do it like that. And if you want to know like, oh, well, Eli, how many indices are there? Well, you can see how many there are right here. There's that many of them and that many of the long. However, often what we want to do is we want to select based on the values here. And if we want to select on the values, we're going to be using SEL, cell. So we give the name of our data set and then .cell. So let's see that instead. I'm going to go ahead and open up another code cell. So I can do DS and let's do cell lat equals, oops, do that. Let's see what happens. Okay. So now what you see is I said, hey, pick that latitude. And it selected that one. And then I have all the longitudes and I have all the times. That's 1, 2, 3, 4. Let's see what happens if I do that. Okay. Yeah. So I just showed that so you can see what happens if it couldn't find exactly that value. By default, it's going to try to find the value that's closest to, or that is exactly what you just put in. However, we can say method nearest, and it's going to find the nearest value. So let's add that. And now it works. So that is the closest one to that. So that's like if you need to do matchups to something, you're going to use method nearest. I think there are other methods. I only ever use nearest, so I don't know the other ones off the top of my head. Okay, so now we've learned iCell if you want to pick indices, and then cell if you want to select based on the values. I should note when I say that, when I talk about selecting and subsetting, that we do need to have the things we're slicing on or subsetting on to appear as coordinates. So they do need to appear here, coordinates. So I can't do that with like a data variable. It has to be something that's a coordinate. All right, so what if we want a range of values? So let's say we want to get the latitude that is between 33.5 and 35.5, so it's 2 degrees, and same for the longitude. When we do that, we use a function called slice, and it looks like this. So it's latitude, slice, longitude, slice. To get those slices, I'm going to use a specific time, which is the start. So it's nice. I can roll over this and I can see that, yes, I did run the code to define that. So that's the start. Let's go ahead and run that and see what happens. And now we have 201 latitudes and 201 longitudes. We have a box and we have one time point. So now we have created this subset. So these functions that I've just showed you, mainly really cell is the one that I see like constantly and I use constantly. There are plenty of situations when you would use iCell, like to select an index, but the cell one is the really common one, and then slicing. The difficulties that I see people have is they try to slice something that is not yet a coordinate. And it's easy to fix that. I'm not going to show you the code. You could put that in a chat bot and say, hey, how do I make something a coordinate with an xarray data set? Okay, so let's talk about plotting. So xarrays have like a base plotting function. And so this is a really great way to just make really fast plots. It's not terribly fancy, pretty. But it's so like it doesn't like if you've seen those plots, like I showed them in previous weeks where you've got like the coastlines and you've got like the whole globe and stuff. For that, you're going to use matplotlib. But there's a lot of times you just need to do a quick plot. How does this look? And so let's start another little code block here. Talk about that. Okay. So to do that, there's a couple things to know. First off, we need to have one data variable, and we're going to need to have one time slice. This is a very, very large data set, so I do want to make sure I'm using the subset, because when I'm going to be plotting this, it is going to load it into memory. So if I tried to plot the whole globe, it would be very slow, and it would also almost certainly crash. So I'm going to work with that subset, that 200 by 200. How do we get a data variable? We can do it like this with square brackets. So let's do that. So now what you see is, first off, it's changed from a data set to a data array. So it's values for one thing, analyzed SST, but it does have features of the data set. It has these coordinates. So it knows that it's a gridded data set. I believe this syntax should also work. Yeah, so you can also use that syntax. So a dot like that. You can also do something like, oops. Common thing you would do is like something like this. Nope, 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 nope. Sorry. Come back here. Did not intend that. Then you can do that. Yeah. So you can do things like that too. Okay, so now I have a data array, and once you have a data array, now you can plot that. So let's see what happens if we do or call this DS bar SSD. So I do that. Great. For those not familiar with Jupyter Lab, I keep trying to remember to like run over and hit that so you can see what I'm doing, but sometimes I get on autopilot, and when I'm on autopilot and I run the code very quickly, what's happening is I'm holding down the shift key and hitting return. That's the shortcut for running code. So now I've assigned it to this, and I'm going to do SST and then do plot. So now I'm going to run that. Let's see what happens. There we go. So now it plots that out. So it'll like just, automatically do that. So like I said, this is a really great way to do a very quick plot of your data array. You can pass in more things if you want to change it. Sometimes it'll be unclear what the X and Y axes are. In this case, it is clear, so I didn't need to specify them. But if you needed to, you could specify X and Y. Okay. So now what we're going to do is we're going to open up multiple netCDFs and make something called a data cube. So rather than a single time slice, we're going to have lots of time slices. So our results that we made up here. Okay, yeah, you can see these results. There's lots and lots of files there. And sorry, come back here. Okay. And we can open up multiple URLs. In this case, we do need Earth Access to help us put a little decoration on those URLs because it is in this cloud data and it does need to authenticate. However, if you had URLs that pointed to, you'll see in the OPeNDAP server, you could have like a vector of URLs and it could open those. It just can't open plain URLs to cloud buckets. Okay, so we got a bunch of these. And now because we have a bunch of these URLs to the cloud buckets, we are going to open those up with MF dataset. So let's go ahead and do that. So remember, massive data sets. This definitely cannot be opening this in memory. One slice is huge by itself, and now we have a number of days here. And now what you see is that xarray shows us nicely what our data set looks like. You can see it has 5 time steps, and then these are the grid longitude. I think that's longitude. Yeah, longitude and latitude. You see it shows us our coordinates. And now what's changed is we have multiple days. So now we have multiple days. Now we can do a slice. We can do the slice on the latitude and longitude just like we did. So we're going to take the DS, that's the data set I just loaded here. It looks like that cube now. And I can slice it. And now you can see it's smaller latitude and longitude domains. It only has 2001 each side, and it has 5 time points, 5 days. If we wanted, we could slice the days. So we can slice from this day to that day and do that. So now we've sliced it down to 4 days. We can plot it easily. So we have 4 days. And so we're going to do the same thing. We take our data set, we make it into a data array by picking one of the variables, and then we're going to plot. I didn't actually need to do X and Y. I guess I put that in there just to make it really clear what's going on there. Here is where I tell it what the columns are. I'm going to have the columns be time, and I do wrap. And that way I can get each of those. So each of the 4 days, just like that. I think that goes pretty fast. Yeah, that was, no, here we go. It'll be pretty fast. I think. I didn't actually run this out. Yeah, no, so it's fast. It's 10 seconds. Okay. Let's see what CI's fraction. Oh, that will not be interesting because I don't think that I'm anywhere near the poles. But let's check out SST anomaly. See what that looks like. Yep, taking longer. Okay, there we go. So now we see the SST anomaly. Looks like wherever I happen to be looking at, it was unusually warm. And then, so this is, I'm looking at some kind of like temperature blob here, anomalous heat blob. Okay, so that ends our sort of learning the basic functions, selecting and subsetting. Next, we're going to see some other things that we can do with data cubes. So we're going to go back here. Let's go back. Okay. Okay. Xarray. Okay. So now we're going to go check out this data cubes one. So, same thing, but now I'm going to open up this data cubes. So we've already made it a data cube. What we're going to do is we're just going to do some new things with this data cube. We need to uncomment this and run. And remember, you need to put that exclamation mark there. Let's do that. I can run anyway. Okay. For this example, I'm going to use this AVHRR SST product. It's lower resolution than the MER data, and it's going to load a lot faster, so better for tutorial. But all this stuff I'm showing we could have done with the higher resolution data. Just be slower. Let's go ahead and import that. Let's go ahead and authenticate. Let's see if I can manage to put my password in successfully. Great. So now we're going to go get this data set. So kind of the same idea, but this time, look, I'm going to get a year's worth of data. There we go. So that's it. I got that. We can take a look at what this is. We can see again, it's pointing to a netcdf file. You don't know this, but it is pointing to data in a cloud bucket. Okay, there we go. Okay, great. So, what I could do is open up that entire year worth of data with this command right here. If you're in Colab, you're going to have to double click on that. If you're in the Jupyter Hub, it would show the raw code. I made it in raw so you didn't accidentally run it. It does take a little while. This is the part that takes a little while right here, opening this up. And it's not that it's loading all the data in, but it has to read the metadata for 365 files, and that takes a little while. So this is that function. This file set is, you can see up here. Oh, sorry. Right here, I create a file set to all 365 files. And then here I open that, I read the metadata. And then what I can do is I can subset that by slicing to this smaller 2-degree slice for that variable. And then I could save it to a netcdf. Now, I wouldn't need to save this to a netcdf. I could have stopped right there, but for the purpose of the tutorial, so that I wouldn't have to like sit around for 5 minutes while it's loading in all of those, I saved it to a little netcdf file. Okay, so to load in that netcdf file, you're going to run this code. What this does is it goes to the URL where my little file that I made is, and it's going to download it to Colab and then open it up. So there we go. So it just downloaded that to Colab, and now we can take a look at this. And what we can see is, to speed things up, I did make it like super small. So it's just 8 pixel by 8 pixel, but it has 368 days. And now we can start to do some interesting things. So we could take the mean, get the mean of this entire cube. So what is the mean for sea surface temperature in that cube in 2020? Well, let's go ahead and run that. So there we go. We could get the mean over space. So this got one value, but we could also get it for, you can see here's our one value, that's our one value, but we could also do this for space. Let's do that. And so now it's for each latitude, longitude. Oh, sorry, wait, no. Take that back, write that back. So what it's doing here is it is averaging over latitude and longitude, and we will have a value for each point in time. So that's why you see it only time appears here. Let me do, I think this should work. Let's see what happens. Fine. I didn't try this ahead of time. No variable name. No. Fine. Oh, what do you want? Oh, there we go. Okay, so it did work. Great. So there we go. So, what I did is I just took those means, and that is the mean in that little cube over time. Another really nice feature of xarray is you can do this resampling over time. So xarray, was developed by the earth science community, and one thing they need to do a lot is create these like seasonal means or the monthly means, that sort of thing, or daily means from hourly data. And xarray has really good functionality for that. Here I'm going to resample that daily data into monthly means. And so notice here I'm resampling the time. I'm not averaging the lat long. So what I'm going to have is 12 new maps for my lat long. And it's just going to do that for me. There we go. All right, did it. Okay. And I think actually probably it didn't actually do the computation. It just figured out how to do the computation and what the shapes of everything's going to be. So that is going to be 12 months. I think right now, as soon as I do the plot, you're going to see that. So now what you're going to see is I can plot out each month and see that mean. So this is the mean month, the monthly means. What are you unhappy about? No. Oh, come now. Come on. DC monthly. What are you? Why? Use explicit. No, that's not right. Okay, I have no idea why. Oh, okay, fine. Fine. Okay, there we go. So it wanted this to be a data array, not a data set. So I had to add that there. Okay, but you can see we now have our monthly means. Just like that. Really nice. We can take that monthly means and plot it out. So I bet I do have to do statistic. Okay, let's see what happens. And there we go. So I can make a time series plot. I could have also done this quarterly. And, I could get that plot. I think I'm missing that analyzed SST again here. And then I could plot the quarterly series too. All right. So that gives you a really quick tour of some of the very, very common and basic functionality from xarray. In this example, what I'm showing you, I did not use the Dask backend. I made the data small enough that it could load into memory. In later weeks, maybe in the next example, I see I've got 10 more minutes. We'll see how the questions are. I may, the next example I have with OPeNDAP, it may trigger that Dask feature, but I can definitely, it's just an argument that I can pass into xarray to tell it, hey, I want you to recognize that this has chunks. Okay, but I want to stop there and see if you guys have any questions about what you've been seeing. Oh, thanks, James. James posted in the options for the method for getting the nearest when you're doing the selections. Okay, yeah, any questions? Feel free to unmute if you want. Or comments. Okay. All right. Were folks able to run that in Colab? All right, at least some of you, or the Jupyter Hub, follow along there. Yes, thank you, Michael. Okay, at least Michael. Great. Okay, so in the last few minutes, I want to show you a more kind of realistic, real work example. And I'm going to show you accessing data on OPeNDAP with xarray. So a really cool thing about xarray is people over time have written these kind of accessor extensions to work with lots of different ways that you might get data. And so there's one for OPeNDAP. OPeNDAP is a really common way that will serve data, especially like gridded data. And there's a, xarray will use this PyDAP underlying engine and take care of all the details for you. It's very nice. So we're going to go ahead and use this example here. So I'm going to put that URL back in here. Yeah, James, well, hopefully I'll get into working with Kerchunk and Virtualizar in later lectures, so you can see, how that works. I also want to give a lecture on IceChunk. Yeah, so farther down the line. All right, so I'm on this page, and we're going to open up this example right here. So we're going to work with this example. It's some model data, some reanalysis data of air temperature from this product here, and they have it on this threads catalog. So let's go ahead, as usual, we're going to open this up in Colab. Okay. And whenever you're working with, or whenever I am working with a OPeNDAP server. I first take a look at their catalog or a searcher. Yes, no, let's go. Yes, let's go there. Okay, great. So I'll poke around on their server so I get an idea of how they name things. So here I can see, looks like they've got yearly files of this, of the variables. Looks like this is, that's the air, and these are some other ones. Looks like they've got a land mask. All right, so you can just kind of zoom through. Just that's what I usually start with. I just want to orient myself on their catalog, their data catalog first. And I want to see what the URLs look like. I can, kind of roll over that, and I can see, as I roll over at the bottom of my screen, I can see what the URL looks like. So let's test that we can open up these. So let's take a look at this. So I'm giving it the base URL, and I'm trying to get all the files at this URL that have this format. They got that base, that dot, and that year, and .nc. How did I know that? Because I was just skimming with my eyes the catalog, and so I could see the format that they had their files. So I can see there's 77 files, so 77 years. Let's see if we can open a single file. So there we go. We want to make sure this is going to be able to work. And yeah, so we're going to send this to xarray, and we're going to open that URL directly. So this doesn't require any authentication. And hey, why didn't you work? What did I do wrong? Did you change something? Oh, I haven't run this for a while. Oh, come on. What is this? Well, darn. That's what you get for not running your thing right away. File not found. Oh. Okay. It may be that I didn't try running this in Colab before. So it may be that I need to install the PyDAP engine. And instead of trying to debug that on the fly, I am going to go here. I can show you that. Okay. All right. So now I'm in the Jupyter Hub, and fingers crossed this works here. And yeah, okay, yeah. So I'll look into what's going on there, because I want to show more OPeNDAP next week. But I am certain what's going on is I need to make sure the PyDAP engine is installed for xarray. So we can recognize, hey, this is a file on OPeNDAP, and yeah. Okay. Do you need to use requested? Let's see here. Oops. No, no, you don't. No, you just have to, because this is OPeNDAP, you need to make sure the PyDAP engine is installed. I have it installed on the Jupyter Hub, and it's just it's probably a pip install PyDAP is what's necessary, and then restarting the kernel. It's almost positive. I would do it, except I only have a few minutes here. I'll start this over next week, and I'll make sure to include the instructions how to install that on Colab. It's not hard. It's just a step. This is a small line of code. But once you do have that engine, then xarray is going to know how to open URLs that point to OPeNDAP. So it knows what to do once you have that engine installed, and you can just pass it the URL, and you can see it's able to open that up. So this particular file is 1948. It's the entire year. You can see the dimensions of this. You can see, the time there. And we can also load up all the years, all 77 years. I didn't actually, 10 seconds. Oh, okay, great. So let's just let that run there. Doop, yeah, 13 seconds. There you go. So all 77 years, we've got all the metadata loaded. Remember, the data themselves are not loaded. It's the metadata. But now that we have this object, you can see here, we can start to do some interesting things with that. You can see lots of days. This is daily data, 77 years. We can do things like plot and what else? Create daily means. Here we go. This is the mean temperature in a certain lot long. Actually, I think this is global mean temperature. We can resample down to day. Oh, goodness, was that hourly data? Goodness, this is hourly data. Wow. Okay, so we are processing hourly data from this. You can see this is pretty amazing. I will I'll pick off where I left off. I'll restart this one so you can start to see some harder problems in action, and also see Dask working in the background to do this kind of processing of this really large. This is a very large data cube that it's processing. And I'll do this live next week so you can see it doesn't actually take very long because it's doing all this parallel processing in the background, and it does not require much memory. I'm on a puny little machine here, 2 gigabytes of RAM. All right, with that, I am going to stop for today, and we'll pick up in the background. Yes, it is using things in the background, Amy, but it's, as you see when I was on the Jupyter Hub, I don't really have to worry about that because PyDAP is handling all that for me in the background.
Yeah, that's great. Thank you. I learned something new today. I appreciate that.
Yeah. Next week, I'll do some more complicated examples where we have OPeNDAP servers that require authentication. PyDAP's going to help us with that too, but we will have to pass it in the authentication information. All right, everyone. Have a great weekend. See you next week. More xarray and more OPeNDAP.
Thanks, Eli.